Black holes. You have probably heard of them before, but no one understands everything about them. Our knowledge of them essentially equates to the color used in their name. But piece by piece, we have built an understanding of them that few could possibly have imagined just decades ago.
Now, black holes aren't a new concept. Ideas on the existence of black holes actually came about as early as 1784, but were not truly theorized until 1916, with Albert Einstein's theory of general relativity proving the existence of points in space with essentially infinite density. Despite seeming like incredibly complex structures, black holes only have one major component: the singularity. This point in space has essentially infinite density.
Most black holes form as the result of supermassive stars, which can have masses as much as 5 to 20 times the mass of our sun. As they near the end of their lives, they collapse in on themselves, creating a tiny point with the mass of many suns put together. They serve as the force holding entire galaxies together with their gravitational pull, which has the special property of being so strong that nothing, not even light, can escape.
Yes, you heard that right. Light, the fastest thing in the entire universe, can't escape black holes. And that's what makes them so interesting. Most people think that black holes are just infinite voids of destruction that just suck everything near them into oblivion, never to be seen again. But that's just not true. That's only the case inside of a certain radius of the black hole. This radius, which we call the event horizon, is the point of no return, where the gravitational pull of the black hole can overcome anything in the universe, even light. Outside of the event horizon, though, some pretty strange things can happen. Here's one example. Imagine the sun were to turn into a black hole, but one that had the same mass as the sun, just compressed into a much, much, much smaller space. Most people would think that the Earth would just get sucked into the black hole and everybody would die, but that's not the case. Due to the masses of the two objects staying the same, the Earth would actually orbit the black hole and would be, excluding the lack of sunshine, completely fine. So, if black holes get rid of all the light that comes within their event horizons, how do we humans even know they exist? Well, we can't actually see black holes, but we can see the effects that they have on light right here on Earth. Here's a fun example of how black holes can warp and disturb light. Let's imagine the Earth orbiting a black hole. As the Earth is in front of the black hole, things would look pretty normal. But instead of disappearing as it went behind the black hole would distort Earth's reflected light so severely that it would look like this. Next time you're bored, think about this. In the early 20th century, astrophysicist Carl Schwarzschild discovered that anything in the universe can become a black hole. You, your computer, a Rubik's Cube, anything at all. The key is to compress it into a small enough space. Picture this. Take the mass of the entire Earth and condense it down to the size of a peanut. That would create a black hole. The radius you need to condense an object to turn that object into a black hole is known as that object's Schwarzschild radius. A little bit closer to home, humans have been able to create a black hole. Okay, well, not quite, but scientists have created the dumb hole. Similar to the way that a black hole does not allow light to escape, a dumb hole does not allow sound to escape. It allows scientists to learn a lot about how black holes treat light by studying the way sound is treated in a dumb hole. While scientists have made major advances in understanding how black holes function and their role in our universe, there are many, many more aspects of black holes of which we have not even scratched the surface of understanding, such as how long they survive.
We actually don't know how long. The universe simply isn't old enough for us to know yet. On the other hand, we haven't been able to identify an origin for the supermassive black holes at the center of galaxies.
That'll do it for this episode of Sucked In. Thank you for watching, and we will see you all next time.